Now let's go through an example where we could put all of these derivations together on the same platform. So we are going to look at 2-unit systems, 2 units in series, 2 units in parallel, where the units are independent, and 2 units where they are dependent. So that's what we just did. So let's approach this step by step. So we have many curves here. They are confusing, so I'm going to explain them one by one. So as I said, these are the 2 things we are going to look at. On the left, the series system, and on the right, the active parallel system. And we'll look at 2 cases when the 2 elements are independent, and 1 where they are dependent, with various strengths of dependence. In each case, the base lambda is 1 per day, and that's whether we have 2 units in series, or whether we have 2 active parallel which are independent, or the same lambda is there for the dependent parallel system where both are working. So that's our base lambda. Then there are 6 of these cases, so let's go through them one by one. So the first is, and that's good to know, it is the single unit. So that is, we have just 1 unit with rate lambda, TTF exponentially distributed, and that's that orange line is the curve which traces the reliability of that system at rate of 1 per day. So the mean is 1 day. Now, with that in mind, let us see 3 of the ideal cases. 2 of the ideal cases. One is perfect series, and the other is independent parallel. So the first is the independent parallel active configuration. So that is the top blue line, and clearly the presence of the second element in parallel makes the system much more reliable, and it's clear from the difference of the blue line from the orange line. On the other extreme is the case of the independent series. So that's what we see, which is the lowest possible situation, least reliable. So that is the third line. So we are now going to stay within these 2 limits, and somewhere in the middle is the single unit function. So let's bring in the active dependent parallel, that lambda and lambda prime that we just discussed, and let's look at it with increasing strength of lambda. So after the first failure, the second one becomes stressed, and that stressed nature increases with lambda prime. So the first case we'll look at, the lambda is 50% more, lambda prime is 1.5 per day. So that is the yellow line. So the blue line, the independent parallel, now shifts downward to the yellow line, and that is because the second unit becomes more stressed. There is dependence. With increasing dependence, that yellow line moves to the violet line. I would call that violet. So that's when lambda prime is doubled. So that's twice per day. And finally, we have the green line, and that is the case when lambda prime is 3 times. So that's all on one graph. We have 6 plots. So in the middle there is that single unit. On the top limit there is the independent parallel. On the lower limit, on the lowest limit, there is the independent series, and in the middle there are the dependent parallels, and it becomes worse and worse as the dependence keeps increasing.